We have learned mainly two different modeling techniques in terms of database. Modeling is not only for the database, it can be widely used in computer science, even engineering, not only for the engineering, in our daily life. Modeling is used everywhere. So we are going to focus on only the database modeling. So what is a modeling? It's a common rule or the constraint that apply the whole data, whole the database that you are going to create. So what kind of the data or database modeling you learned so far? We learned first entity relationship modeling, and what else? Relational database modeling. Are they the same? It's a different modeling, but not entirely different. Okay? Some of them are very close, actually very close database modeling or data modeling technique. However, anyway, they are different. What is the different thing? ER modeling and relational database model. What is the main purpose, objective of ER modeling? Define the only relationship. Why do you need a relationship? You'd like to find something common rules or common characteristics that apply for your information. So for example, we are going to build a university database. First, you will get lots of information around the university. Right? Even you can have the student information, faculty information, staff information, course information, but sometimes the number of desks are the information, and temperature, how many verbs are in this classroom, and how many blocks are in the site. So many huge information. Are you going to manage all of this? Definitely not. In terms of information, it's the everything around the university, UB, University of Bridgeport. However, we are not going to manage all information. It's not possible sometimes. So you need to select this certain information. So that step is called modeling, especially data modeling. So we'd like to make the data. So we define the data, definition of the data, definition of information. That's not the general definition. It's used in database. Somebody may argue information is not all the information. It's a definition in our classroom, in our database community. So information are everywhere. We are not going to manage the information. Instead, we need the data. What is the data? Data is organized information, important information. So we call that is the data. However, when we are doing the modeling, so from information to the data, for example, all the information at the university, we need to find the student information, faculty information, course information. At that time, did you consider any of the specific DBMS system? Did you consider any specific database? No. At that time, at first, we need a certain organized concept in our mind. Okay? We do not use any tools or computer, just pen and pencil and paper. That we'd like to represent such a complicated or the huge bunch of information. We'd like to find a certain data is the data modeling. Okay? For example, when you are doing the programming, so you are asked to build a program to sum up 1 to 10. Okay? So when you learn the first time your program language, probably you learned about this kind of thing, right? What is this? So flow chart. Okay? So before we start the coding of this one, before we use the C C program language or C++ language. Before that, we should understand how it works in terms of such a process, because computer can understand such a process step by step. At that time, do you consider any computer? No, you don't need. Do you consider any program language? No, it's just conceptually designed. You can apply this algorithm to any computer, any program language. Okay? This is conceptual design of your program. In ER modeling, what did you do? We finally identify such an ER diagram, right? Entities and relationship. Do you consider any specific DBMS? No. Do you consider any specific database? No. We just consider information and data. Conceptually design your database. Okay? In your brain, in your mind. Okay? That's enough. Okay? Sometimes you can skip. If you are very, very familiar with your database, you have everything in your mind, then you can start creating. Right? Just a simple student table. That's the only one, only information. Then you can create it. At that time, that doesn't mean you don't have to do this one. You can just skip this process because you already have it. Because that is simple, or you already know it. So this is called the data model or conceptual design of your database. So from information, what is our goal, final goal? We try to build a database. Where? On computer. So however, as I said, computer is not a smart. Computer cannot do anything. Computer can do only process, understand, structured data. So well-organized data can be understood by computer. Okay? So from such a unstructured information, this is information everywhere, they are not structured. We first find such a logical concept of your database information. That is ER modeling, data modeling. Especially we select the entity relationship model. It can be use case. It can be object-oriented model. It can be UML model. It can be the network modeling. Among them, we select entity relationship modeling technique. That is the data modeling. On the other hand, we learn relational database model. Who proposed the relational database model? Dr. E.F. Code, around 1970. He thought about is there any convenient and efficient way to manage very large data, but the data characteristic of the data is very complicated. Okay? At that time, he considered certain specific database, specific system. Okay? He does not worry about any information that is already done. Okay? He thought about is there any convenient way or efficient way to very large the data? To do that, we should have very solid rules or regulation policy. That is modeling, especially database modeling. To build a database, we need a certain rule. So he considered what? A relation, a set theory. What if we use the set theory to define the data? Because set theory is already done in mathematics. It's a very solid rule and the methodology, and also we can utilize a bunch of benefit of the set theory. Also, it's easy to make the data structure because it's a set. Set is because actually computer science, data structure comes from the mathematics. It's a part of mathematics. So it's very close. So at that time, why don't we consider data as a relation? Relation has what? Bunch of data, a set of data, a set of tuples, a set of the rows, a set of the attributes. Also, the other relation has the same thing. Each relation should have what? Primary key. primary key should be unique to represent the data. So we can use underline. However, if the data primary key is null, you cannot identify. It's a unique still, but it's not possible to find the specific data because no way to compare null data. So we can specify the primary key should be non-null and unique. Another rule of the relational model is sometimes this attribute should depend on other attribute, other value. Okay, at that time, this one is called the referencing, this one is called reference. Referenced one should be identified. To do that, it should be unique and not null. In other words, always is a primary key. However, referencing doesn't have to be primary. Sometimes it's part of key, sometimes it's not. Okay? Then we can design the arithmetic relation. So this one is not this one. This one should be this. Okay, sometimes primary key can be the composite key, and this is called relational database schema diagram. Okay, so after you got this relational schema diagram, it's not very difficult to create the database. Each of them will be tables. Some of you guys already know before you take this class, right? I created a table using Oracle database. You can download the Oracle software from Oracle website. It takes 2 hours, 3 hours, 2 gigabyte size, or sometimes 4 gig. Anyway, download, then install and create. Then I had an experience. No, that's not enough. You can create whatever you want table, but you should know how we can get such a table. Table actually from each relation. Okay, this is a student table from student relation. If you design already, you can just follow the syntax. So that is the reason I'm not teaching details how to create the database. I believe you guys can do that by yourself. If you know the concept of how the table was born, okay, the basic of the history of the table actually comes from information, data modeling, database model is all set. The only thing is very specific rule. To study the rule, you are much better than me. Okay? You can just read a manual or Googling or find the commercial vendors website, Oracle website, Informix website. Each of the company has their own rule, but fortunately, as long as the commercial software DBMS follow the same relational database model, almost 90% of the syntax are the same, common. So you don't have to worry about too much to learn the software, because you already know one of them. Then it's not a big deal to catch up the other software because they are using the same database model. So we can create the table. Also, we can create the foreign key using SQL, structured query language. We will learn later. Structured query language, probably after the spring break, after midterm division. Then this is the database created on the computer. This is the computer of the server. In your server, you can create the database. In the database, you can create each table, foreign key, primary key, and insert the data. Okay, that is our goal. But that's not enough, because why do you create such a database? Why do you build your house? Because you want to live in that house, right? We want to use that database. So from application progress, Sometimes you can use the database directory using, for example, SQL Plus. You will learn later what is the SQL Plus. Any software you can directly connect or get the data. Or you can use web service, you can use the C#, you can use the C program, you can use the Java program. Anything application program, you can get the data. Sometimes you don't need such a database. If your data is quite small, you can use your memory. Define integer I, then insert the I. Or sometimes you can read the data from file. Fopen the file a.txt. That's your database actually. But that's quite small, that's enough. So memory is enough to manage the data. However, when you have a very large database, data is not possible. So to speed up, too easy to manage such a database, you can use such a model and created a database. Okay, so we learn this modeling and this database model. Okay, actually this is a page 1. You already done. And this is a page 2 in your project. And this is page 3 in your project. And this one is page 4. Okay, you are going to do these 4 pages in your database project. This is not only for this, the classroom database project. Any database project have the same basic step. Okay? Sometimes you may join only part of this as a database program. Or sometimes you are joining the conceptual. This is called conceptual design because it's done by conceptually. Okay, we don't need any physical database. So conceptual model. So you can join this group at the graduation. At that time, you should know. You should be expertise on this data. Like if you are building the bank database, to model conceptually, you should know everything. Money flow, how it works. Okay, so that is the reason many of the conceptual designs done by financial group, CPA, certified professional accounting, or consulting group. They are doing such a conceptual model. Do they know anything about Oracle? No, they do not know. They know only business flow, but they can do conceptual modeling. Okay? It's very expensive. High salary, high payroll. Okay? Also, that is a reason, for example, technical management. We have several students from technical management. It's very good for such a, they are doing the business and technology. So it's a benefit. Also, sometimes the business school of business teaches the basic of computer. If they know about such a physical database, it's helpful. That doesn't mean they should not know this one. If they know the database model or physical database, it's much easier or more helpful to build a conceptual design. Okay? So that is the reason usually I allow the technical management student to take this course, but to do that, they should know. I'm not teaching this part of application. It's a prerequisite. We don't have enough time to teach even the programming. Okay? Then, page 2 is the database design. Okay? So, page 2 and page 3 will be physical database. So, this is called physical database modeling. What is the size of the table? What is the location of the table? Are we going to put the student table with the faculty table? Sometimes not, sometimes yes. And how do we create the index? How do we manage the constraint? Are foreign key constraints enough to keep all the constraints? No, sometimes not. Also, sometimes many of the programmer or database administrators ignore creating foreign keys. That's true. Why? It's difficult to manage. Okay? So, That can be done in the physical database model. Then finally, database programmer will use such a database that you created. So you need to do up to the page 4, the database program. Okay? This is the overall thing that we have done so far, or we are going to do the last of the semester. Then, today, we learned this one, ER modeling. We learned this one, database modeling. They are similar, but anyway different. Their main object, main target, main goals are a little bit different. So sometimes you can do the relational database model directly. That means you already know such a rules or constraint or the concept in your database already. So you can directly create. But most of the case, when your customer bring the whole huge bunch of files or huge bunch of report, so you need to find the rule by yourself by reading or analyzing the request. So at that time, you better start from the conceptual design. Then, we need to do this one separately. No, you don't have to do that. Sometimes the ER modeling, relational modeling, as you can see, is quite similar. Even when I'm explaining the concept of this, I use the entities instead of the relation by mistake. But they are actually quite similar. That is the reason sometimes I use interchanges. That's not good, but it happens a lot. So that means we can make a relational database schema based on ER modeling. In other words, we are going to convert the ER modeling to relational database modeling today. Then, from information, we can have relational database schema through ER modeling. Okay? I know when you are doing your project, sometimes many students can create it directly. I can do the database by myself without this. Yes, you can do that because it's quite small database. You know where your database is, so you understand everything, such a relationship or the condition, so you can create it. But this is the class where you are learning how to design and how to build the database. So please follow step by step. Okay? I know some of the students submit already the SQL script to create your table. Okay? So that doesn't mean you can get the full credit. Okay? We are learning step by step using real coding. Okay, then how to convert? How to map between ER model to the relational model? It's not very difficult. It's a straightforward way. We can follow just step by step. Before we start such a mapping, first we briefly go over that we do not finish the last time. So this is the what's the name of database? The course enrollment, student enrollment in courses and books database. Okay. So even though I do not mention detail, do not describe the details of the condition, using this information, can you find any? We have already primary key. Primary key. This is the one primary key, okay? It's not the key. This is not the key. This is one key, primary key. This is one primary key, one primary key. Can you find foreign key? As many foreign keys as possible. Okay, so what can you find first?
SSN.
Which SSN?
S enroll.
SSN enroll. Left first. SSN in student. Always the destination left one should be primary key. That's the rule. What about what else?
Course number.
Course number in row.
With
Left
course
part,
number in course.
course number in course. And similarly, course number in book adoption, refer, course number in course. Others.
Book ISBN.
Book ISBN, which one?
From
book
adoption.
Adoption.
Is the
Text.
To book ISBN in text. Are they all?
Quarter in the book.
Quarter in
Book and
book adoption. To quarter in row. Or quarter in row. To book adoption. Which one is first one? So number one. Number two. Number one. Number two. Down. Number three. Neither. Number three. Answer is number three. Okay? Why?
Quarter isn't sufficient primary key.
Primary key. As I said, destination, referred. The second part should be primary key of that relation. Is that the primary key? No, it's just a part of primary key. What about this? No, it's just part of primary key. So there is no constraint between them. Okay? Which means it's just part of the primary key. As long as it's unique to make them unique. Also, non-null is okay. Which means for the same quarter, for example, I enrolled for 2011. Okay? So for 2011, you insert the data, populate the data, FALF 2011. However, you can populate here F11. That's not allowed if there is any foreign key constraint. However, here, no foreign key constraint. So it can be whatever. So, how can you address that problem if you want to keep the constraint? You need to create.
You can take both the course number and quarter as one primary key.
It's a one primary key actually. It's a composite primary key. We need to create a relation for quarter. Okay? So quarter, we have another relation for quarter. Then quarter has the foreign key. Then if you have more information about quarter, for example, starting date of the quarter, ending date of the quarter, okay? Then you can have another relation. However, I guess the owner of this database, so quarter is not that important to keep such a constraint. As long as it's a part of the data, the primary key, it's okay. So that was the reason the designer ignored such additional information. Okay. Another way to keep the consistency of that quarter in your application program. Whenever the data is inserted, you need to check whether name is correct. Okay? Name exists. You can select. You can find such a data. Yes.
With C#, you can make a drop box.
I don't know anything about the C#, so we don't have to worry about the C#. That makes us confused. Okay? So in your application program, you can put your rules or regulation or policy to make the quarter. Okay? So that's another way. That's actually frequently happen in real database. Even we can do the same thing for any constraint. Primary key, you don't have to create a primary key. Then you can check in your program. Whenever the new data is inserted, check whether there exists or not. If there exists, no. If not, you can insert. You understand what I'm saying? But we are not going to consider such the secondary method or alternative way.
So now, how many primary keys we have at all?
Either 1, 2, 3, 4, 5. It should be, must be 5. Why? According to the relational database model, each relation should have one primary key. Okay? That doesn't mean we have 3 primary keys. One primary key has 3 attributes. It's a composite primary key. That's the difference from name and the department number. In department, that is the thing, difference between the ER modeling and relational modeling. In terms of according to the ER modeling, each entity may have several keys. However, according to the relational database modeling, each relation should have one primary key. Okay? So how can then we can start the mapping from ER modeling or ER modeling to relational database model. So simply from ER modeling, this diagram, our goal is to make this relational schema diagram. Okay? Can you understand the goal of this chapter? So that's easy. How can we do that? Just follow the step. From 1 through 7 for ER modeling and 8 and 9 for enhanced or extended ER modeling, specifically generalization or specialization. The reason why we consider ER model extended or enhanced part separately is even though relational database model is easy to learn and very effective to manage the very large database, however, it's not very flexible. In other words, it cannot accommodate, it cannot solve the very complicated relationship. Actually, in our daily life, in our real life, there are many complicated relationships. However, in the relational database model, it cannot take care of such a complicated one. So we need to use alternative way to do that. The one example is, can you remember one of the rules in the relational database model? Each value of attribute should be what? Non-null? It can be null, it can be non-null. However, it should be atomic value, which means non-divisible value. It should be atomic, it should be one value, okay? That is a relational database model. Sometimes you cannot understand why a value should be just one. Sometimes we can have the set of data, like the vector in Java, okay? Or array. What if we consider, no, relational model cannot take care of such an array or set of data or the multi-valued one or divisible data. So that is a rule that makes us easy to use the relational model actually. Okay? There are, so true, anything in our life is a pros and cons. It's a benefit and disadvantage. Advantage and disadvantage too. So we need to take care of such a complicated relationship separately. We will take care of the next class today. We are going to learn the basic general step to convert ER model to relational database model. First, so what was the first step when, no, just a little bit. What was the first step when we are doing the ER modeling?
Identifying relations.
Identify entity first.
It's relations.
Yeah. So we identify the entity first, then find the relationship between entities, right?
I didn't say relationships, I said relations. You told me that relations are...
Relation is in the relational model. Okay? It's a different thing. So even though I'm saying the entity for relational model, that's my mistake. Do not follow my mistake. That cannot be excused. Okay? So we started from identifying what? Entities. So first we are going to convert. Map the. So step 1. Entity. So ER model is a relational model. So entity will be what? It's easy. I already mistake a lot. Entity will be relation. Okay? One entity will be relation. Especially only strong entity. Which means when you have the key, actually we have the keys, many keys, like number, D, number and name. We need to select one of them for primary key. All the other general attribute will be attribute in relation. What else? Composite. Composite attribute will be only some component as an attribute. For example, this is address. This is street name. This is the state city name. This is the state information. You can create attribute for only this, not address, because relational database model does not allow what? Composite value. Okay?
Yes.
So only the single value. So we are going to take only sub-component. That's it. That is the first step. Okay? Then we missed one thing. What was missed? What is missed here? From entity.
Wait.
Foreign keys.
Foreign key is not entity. Foreign key is the concept of a relation.
No, you are talking about inside the entity.
Inside the entity,
Okay, keys.
there is no foreign key inside the entity. Entity is the ER model. Yes. Relationship is between the entity. We are taking care of only entities.
Multi-value.
Multi-valued one. So there are three types of attribute: general attribute, composite attribute, multi-valued one.
Yeah.
Multi-valued one, that is actually a problem. So how can we solve? Just ignore. We will take care later. Okay? Except the multi-valued one, we can convert any entity into relation. So can you see how many entities can be converted into relation from this here diagram? How many entities do we have? One, employee, department, project, and dependent.
Four.
Among them, how many of them have primary key? Not primary key. 3. Dependent actually does not have. It's a weak entity, so we can create for employee relation by following the step 1. What is the primary key? SSN is on the line. We have only one key. Then the other, B-Day. If you cannot see it, you should have the handout. Okay? Chapter 7 and 8 handout, you can see. B-Day. And what about the name? Name has F name, middle name, initial, and last name. We are going to convert sub-component only, not the name. No, name cannot be handled here because that is the composite. So, first name, middle name, initial, and last name. Then address. Address is, in this case, address is not composite. It's the general, the attribute, salary, and sex. What about the next? Department. So what is the key? Primary key. Name and name or number, right? That doesn't mean we have a composite key. Name can be key. Also, number can be key. That is ER modeling. However, in relational model, we should select how many? Only one primary key. What do you want? Whatever. But you should be careful when you decide a primary key. Because primary key is like your name. Okay? Every parent wants to make their children's name popular or good, better, and so on. Right? So here, name, number, you can select whatever. However, you need to consider what?
Employee name.
Unique.
Both of them are unique.
Must be unique.
Both of them are already unique. When you already done the ER modeling, when you did the ER modeling, you select the key.
Then the requirements of the customer.
Requirement of the customer. Okay? So you need to see the requirement. In other words, you need to see your program or transaction. For example, if your program accesses your database, department database, using name, so your program always search the name to decide the department. At that time, name can be your database. Vice versa. On the other hand, if your customer's requirement or program or transaction use a lot number, the number, you can select the number as the primary key. Also, you need to consider what? Performance. Both of them are equal. The name or number can be used equally. At that time, you should consider performance. Which one is faster?
Number.
Definitely number is faster in computer. Also, you need to think about the future use. Who knows? There might be a chance, even though that is the rule that you identify from existing data. Name is unique, but who knows? In the future, we may have the same name of department. That's sure. So using this category, you need to decide. If I were you, I'm going to use number. Also, if your project team has the specific naming rule, probably if you are joining existing project or existing department, existing company, that company may have naming rule. Like we are going to use one letter from the relation or table, like the D, then number, to differentiate from other number, like this one. This is the project number. Okay, that's not mandatory, but you'd better have. So follow the naming rule. In your project, it's the same thing. Do not make the table name as T1, T2, T3, column name C1, C2, C3, no. Okay, you need to consider the specific name that interpret, that explain the semantic meaning of your database. Okay, then the number is the name. What about the location? We are not going to consider location multi-valued one. Okay, later we will consider. Any other? Yes. Then the project. So same thing, name and number. So we are going to select the number. P number and name
And location.
And in this case, it's a single value, not multi-valued one, right? It's not double over. So we can use the location. That's it. That is a step one. The next step is weak entity. Step two, weak entity. Weak entity will be mapped into also relation. A relation. We can create a relation. To be a relation, it should have, according to the relational model, it should have primary key. Unfortunately, we have only part of key that cannot be primary key. So how can we make them primary key? We already identified the identifying relation employed using double diamond, right? We can use primary key of the primary entities. That is social security number plus name as a key. We can use that for primary key with the PK in identifying relation. That means employee in this case. Okay? So we can create dependent. What is the primary key? Name plus SSN. That doesn't mean we have two primary keys. This one primary key as a composite primary key. Then birthday, sex, and relationship. Is that all? One more thing. Where do you get the social security number? From employee. That means this social security number should depend on social security number in employee. So one more thing. We need for the step 2. We need to create the foreign key to that primary key. So foreign key is from this social security number to primary key of employee. Okay? So that is a weak entity. So we already take care of all entities. Half is done already. The next step is what? Relationship. Okay, this is entity relationship model. So we already took care of the entities. The next step is for relationship. How many different types of the entity in terms of cardinality ratio? What is cardinality ratio? One to many, many to many, one to one. Actually, you learn same thing in your elementary or the junior high school math in that theory, right? One to one, one to many, many to many. First, we are going to take care of the one to one mapping. So step 3 is one-to-one mapping. For that one-to-one mapping, there are different ways. Okay? So, first, why don't we see the example? Do we have one-to-one relationship here?
One-to-one? Yes, managers.
Which one is one-to-one? Managers. Managers is one-to-one between employee and department. In other words, one employee manages one department. One department is managed by one employee. Okay? So what is the attribute of managers? We are going to keep track of start date of the manager. Okay? So in this case, first, there are several different ways, actually 3. First way is we do not create the relation. We do not create the table instead because it's a one-to-one mapping. So one is to one, right? So any information about the manager can be part of employee because it's one. Or it's a part of department. In other words, we have Lee, James, Patel. This is employee. This is a department. Department, HR, payroll, administrative. One-to-one, right? So we start date January 1st, February 1st, March 1st. We don't have to create separate relation. Instead, this one can move to attribute of employee, Lee. Attribute of James, attribute of Patel. Or you can move attribute of the HR department, attribute of the payroll, attribute of administrator. Because it's a one-to-one mapping. Okay? So either of them you can move. So you can move attribute to either of relations. Then the problem is which relation? This one or this one? Actually, any of them. There is no problem. However, we need to decide one of them. How?
Well, logically, the employee, if he is a manager, it should be an attribute of the employee.
Any others? It can be any of them actually. Logically, it's not a problem.
It can be a bit hard.
Yeah. General answer is it depends on. Like others. Depends on what?
Requirements.
Requirement? No, in this case, not requirement. It's a performance. For example, how many employees do you have? For example, 1 million. How many managers do you have? Only 3. Because of the 3, do you want to create separate attribute? All the other, almost 1 million employees may have null data. Null does not mean nothing in physical. In physical database, you need to keep certain space to manage null. Logically, null is nothing, but physically, you need a space. Okay, that's null. So, because of the 3 person, you need to create the attribute. Instead, if we move this attribute to department,
Yes.
all department has manager. It's a minimum 1, maximum 1. But this one, minimum 0, maximum 1. So we better move to this. Okay, so we can add their start date to here. But still, we do not know who is manager. Right? So we need to keep manager SSN attribute. That's it. Manager SSN is employee. That means foreign key. So we need to create the with foreign key. Move attribute, then create the foreign key to other. If you select the employee as the relation to keep this one, you can keep start date and main department and managing department, then create the foreign key to here. It's a opposite way. Okay? This is the first option. So I decide to use this option. The second option is this is a one-to-one mapping. In other words, this one Lee HR, James payroll, Carter is administrator. Why don't we merge into one? Because it's a one-to-one mapping. It's a one-to-one dedicated, which means it's together. It's not actually same because anyway it's a one-to-one mapping. So you can merge into one relation. So you can merge employee and department. Not always it's a good idea. Why? Anyway, employee and department are different meaning, different